Hey guys, it's Simon and welcome back to the next part of the LibGDX Kotlin RPG tutorial series. So in the last part we learned how to create a texture atlas to improve the render performance, and we are now rendering a player entity and a slime entity in our game with the regions that we read out of the texture atlas. And now in this part we are going to make it a little bit more exciting, because currently it's just some static images, and in this part we are now going to introduce animations so that we see, for example, our player running and maybe the slime just idle around and hop up and down a little bit to make it a little bit more exciting. So this is still, I would say, some basic setup for every game that you might need. And yeah, so let's start with that. So since we have introduced our entity component system, what do you think that we want to have for an animation handling? You are right, we will introduce a new component which we call animation component. And what I usually do, because I do not like to have a lot of hard-coded strings in my applications, because that tends to typos, so that's why I usually introduce enumerations for such purposes. So for our different animations that we have, we are going to introduce a so-called animation type, and there, for example, we will have an idle animation, we will have a run animation, attack, def, and open, for example, for the chest, and that would be it. And how does that work? So let's first of all look a little bit into our texture that we currently have available for our player and for our slime. So when we open, for example, our player, then we see a big texture, and we already know what is a texture region. So how does an animation work? It simply goes through the different regions step by step, and you can then define so-called play mode. So everything, all of that is available in LibGDX already. So a play mode of loop would be that it goes through, for example, those 6 frames and then starts again at the beginning. Then there would be a play mode normal, which means that it just goes through one by one and then stops at the end. Then there would be ping pong, so it goes back forth and then backwards again, then loop, reverse, and yeah, there are a lot of different play animations or play modes that you can choose there. But the important part is that an animation is simply, let's say, a list of texture regions that you go through over the time. And yeah, LibGDX already supports that with a so-called animation class. So what we need for our animation component, let's make it a data class this time, makes it a little bit easier for debugging then. So first of all, we need an atlas key for our base model, let's say. So let me open up again our texture package project from last time, so that you know what I mean with that. So the atlas key would be the key of the texture that we are looking at, or the region of the atlas, let's say. So here, if we want to have the player, then we need to pass in the atlas key player. If we want to have the slime, it will be slime. So this is like the, let's call it the base model of our animation. Then we need a time, so how long are we already currently within that animation. That time is then used to move forward through the different texture regions and then actually achieve the animation itself. And as mentioned, we need a play mode, which comes from LibGDX. So first of all, we need the animation, and there is a play mode, and as a default value, let's choose the looped version. Okay, and with that information, we are going to create then an animation, which is nothing else than an animation of, in our case, it's a texture region drawable. So what is that? So first of all, the animation is this LibGDX stuff for 2D animations. And an animation needs to be of a specific type. So it's what kind of things are looped through, or what kind of objects does it go through the specific time frame. So it could be an animation of textures if you are working with textures. It could be an animation of texture regions if your animation consists of texture regions. It could be of sprites or whatever. In our case, it's a texture region drawable. And what is a drawable? This is just a specific wrapper for a scene 2D for an actor. It's simply a texture region, but on top of that, so why is it a wrapper? It knows, for example, how to render itself with the given patch from the sprite patch from the stage and things like that. So our animations will be animations of texture region drawables. And then, so here we are not just using a data container, a stupid one. Here we are going to introduce some let's call utility functions to that component, which is then easier to use it. And one function would be, so we set the next animation of our entity. So there we specify first of all what is the base model, so the atlas key, and then we also define the type, so what kind of animation do we want to play. And in that case we set the atlas key in our component, and we also set the next animation that we are going to play. We did not define that yet, so let's do that. So that will be simply a string that we are going to set, and with that string we get out the animation of our texture atlas. So what will it be? So for the time being you just need to type that down, and it makes then more sense when we implement the animation system itself. So what we need is, first of all, so there are a couple of steps that we are then doing in the near future. So first of all, we split up this big texture that we have currently, and we split it up into several small textures actually. So we will have, for example, 6 separate images for the idle animation, 6 separate textures for the run animation, and so on. And when we pack that then together, then in the texture atlas it will be stored as player / and then the animation type. So for example, idle, and then the different indices. We see that then when we go into that, but we will have then something like this. So for example, player idle 00, 01, 02, and those are the different regions then in our atlas, which then make up the entire animation. So that's why first of all we need this base model information, so the atlas key of the base model, let's say, and then we also need the information of what kind of type of animation for that specific model we want to play. So for example, the idle animation. So in our animation type, where we have that defined, usually those are in capital letters, because this is, I think, just how you define enums, usually the constants. So that's why we need a separate atlas key, which is a string, and that one is simply the toString version of the enum, but in lowercase format. So this is how we will name our file, our animation type. We could of course also name that in capital letters. I think it's up to us, but for that game here I just chose the lower case version of the strings. So that's why, we will stick to that. And I think that's already it. Yeah, so we have the base model, we have the state time, we have the play mode. We will create the animation then in the animation system in a moment, and we can set the next animation. So what we can then do in our game screen, we could, for example, add here already an animation component, and we initialize it with the next animation, and that would be player. And for example, we want to play the idle animation. So something like that. We could also introduce an enumeration for the different model types, but yeah, I did not do that in the code base. Don't ask me why. It's just as it is. But of course, you can introduce here an enum for that as well, if you want. Good. So before we create the animation system, let's now fix our graphics a little bit. And since we have already a raw assets folder, we can easily work with that. I don't know what kind of applications you have available to split up a graphic into several pieces. So if you have, I don't know, Photoshop and there is a nice plugin for that, then please use that. Unfortunately, I don't have that. So what I am using is ImageMagick. So how does that work? So I open up here a command shell, simple as that. Let's change to the CMD version. And then we want to split up, for example, the player graphic. And how is it working? There, if I remember correctly, this is the command. So this ImageMagick has this magic tool. And then we convert, for example, the player PNG. We want to split it into 48 by 48 because that is the size of one frame of the player animation. And there, let's just put it into a folder, player, and call it, for example, frame. Then a number, a running number for every frame, and it's still PNG format, of course. Did not work because I think we did not have the folder there yet. Let me quickly create it and try it again. And that's it. So now in our player folder, we have the different frames. Everything that is completely red is just an empty image, so we don't need that. We can remove that. And now it is a tedious part. So now I would need to see what kind of animations are part of the idle one, what kind of animations or frames are part of the run animation. So for example, I know the first three are the idle one. And then I would need to rename that. So idle 00, then we have idle 01, idle 02, so on and so forth. But I will not do that now in the video. I think you can imagine how tedious that is, and I have no better working approach for that. So if you have some nice ideas for that, or maybe a plugin that helps with that, that would be great. But just that you see how I do it. So I split up the big texture into these pieces, then I rename everything manually, and once that is done, then I can pack it together. But again, I won't do that in the video, so I now just copy over the different pieces and the correct namings from the original project, and then I show you how we pack that together in our texture atlas. Good, so here I copied over now this game folder from the raw folder of the original game, and there you see I have already named everything correctly. So attack 0 to 03, then def 0 to something. So all of that is available. Same for the slime and same for the chest that we did not introduce yet, but just that we have it available. For you that you don't have to do that yourself, you can simply download, of course, the final assets and the final graphics, for example, from the GitHub project. Or if you use a different asset pack for your game, then just do it, whatever you need to do. And once you are done with that, you simply open up the texture packer, and now we pack something differently. So let's remove the one that we packed before, and now we introduce or add a different folder. So now we add this game folder. There we need to set a specific property because it needs to run recursively, so that it also goes inside the subfolders of that specific folder. And I think that should be already it. So let's pack it and let's see. And to make it a little bit nicer, let's say this should be a grid layout. Okay. Yeah, that looks perfect. So that is what we want to have. And now you see, so we have the different small frames of the entire animations in here. And you always see the naming. So it's player because the folder name inside here is called player. Then the animation type, so for example attack or def, that is simply the file name that we have here. And because we use those numbers, so this _00 to 03 and so on, we also have a certain index for every frame, which comes then in handy in a moment when we write the animation system. So for example, this is the player attack frame 1, this is the frame 2, frame 3, frame 4. So this is this bracket 0, 1, 2, 3 here. So that's the index of this animation. Then we would have a player def animation and so on. So this is now the key of the texture atlas that we use in our code. So that piece here, this is this animation key that we are then going to look up in our texture atlas. Good, so the next part is the system then actually that we are going to develop. So let's create a new class here, an animation system. On what kind of components do we want to work? So an entity must have an animation component. And it also must have an image component, because what we are going to do in this system is that we update the drawable of the image actor so that it always represents the correct frame of our animation, so that that one gets updated automatically. So for that we need to implement an iterating system again and implement the onTick entity method. What else do we need? So we need our texture atlas, where we get out the different animation frames, and we also need the animation components and the image components. Okay, then so that we don't forget it, let's move it, or let's add it to our world configuration. So we need a new system, which is the animation system, and we're going to place that before our render system, because here we are going to update the drawable of our image actor, and for the render system we need that to be already available already, so that it can then draw the correct image in the end. So that's why we place the animation system here first. And we need to inject something else so that all our systems and component listener have access to that, which is the texture atlas, so that our systems have that now available. Okay. So now what we want to do is we want to check if our animation component has a specific animation set, so which is not empty. So going back here, you see we have initialized it with the empty string. Let's also give that a more meaningful name. So for example, this is a no animation. That is simply the empty string, which we can use here instead. Then it's a little bit more expressive, would say, when we use that now in the animation system. So as mentioned, first of all, we need to get this animation component of the entity. That we are doing via the mapper. And then we check if the animation component of next animation is equal to no animation, so this means that we don't want to change the animation. So whatever we have currently, we simply want to update that. And what we do there, so from our animation component, our state time, we increase it by the delta time, so that the frames of our animations are then moving forward. Then also from our animation, we set the play mode to the play mode of our component, so that we set here that it should be played in loop mode or normal mode or whatever. So that could change. So we set it here. And finally, we want to get the region or the frame of the animation that we are going to set then on our image actor. So there we, again, from our animation, we get the so-called keyframe in that scenario, and that would be now from our animation component the state time. And this returns a frame, but so a so-called keyframe, which in our case is a texture region drawable, as you see it here. And that is what we are actually want to set for our image actor. So we get the image component, and for the image we set our drawable, and now we set it like this. So this is the return value. And here we need to implement now the remaining logic. So what we need to do now is we need to get out, so whatever animation we set here, so for example the player attack animation, we would need to get out now those frames which are related to the player attack animation and create a GDX animation object out of it. And reading out regions from the texture atlas is again a little bit of an expensive operation, so that's why you should always try to store that. And we will do that as well, so that's why we introduce a cache for that. So we will have an animation cache, which is simply a mutable map of a string. So this is our animation key, so the next animation key that we are using, and that one is then returning an animation of texture region drawables. So if it's available, we simply return it from the map, and if it's not available, then we create it. One might ask, why am I not using the GDX collections here? Because GDX has their own, I even forgot their names. I know they have a GDX array, for example, I think. Or is it just array? Yeah, so that one has a name clash. So we have the array from Kotlin, and then there's also the GDX array. I think with LibKTX we actually have a type alias name for that, so it would be GDX array. Then there are also maps there. I really forgot the name of those maps. And the purpose of these LibGDX collections is basically to reduce the garbage collection amount, because when you iterate over a collection, you will always create an iterator, and that object then of course needs to be cleaned up by the garbage collector. And nowadays I don't care a lot about those optimizations anymore, because in my games it seems like I never have any performance issues or garbage collection issues. So that's why I simply use whatever is available in the standard library, because the Kotlin collections have a lot of nice utility functions which make coding more fun and easier. And as long as I don't need those optimizations, I simply skip it and stick to the standard library. So if you find out that you have performance issues and maybe your garbage collector is kicking in all the time, that's why you have some stuttering every couple of seconds in your game, then it could be that you are using the iteration of a specific collection too much, and that is causing too much garbage collection. Then just move on to the GDX collections which are available. But if you don't have a problem with that, then I would suggest simply stick to the Kotlin collections, because it's easier to use them and easier to read. So that's why here we simply use the mutable map of the Kotlin standard library. Okay, and what we want to do now, so here we know that we want to have a specific animation. So what we do, we get this animation. So from our animation component, we are going to set that with a new function, and there we pass in this next animation key. Then the next thing that we're going to do is that we clear then the state time because we start a new animation. And other than that, we simply do the same things as we did it above. So we set the play mode of this new animation and we return the keyframe, which I just note this is actually the same in that block and that block, so we can extract that, I would say, which makes it a little bit easier. So why not do some optimizations if we notice them through within the tutorial? So we can write something like this. Okay, so what is the animation function? This one now will look up if the animation is already in our map, and if not, then it will create it. So let's create this function, and it gets in any key path, let's call it like that, and it returns an animation of texture region drawable. Crazy long word. Okay, and here we simply return from our cached animations get or put. So either we find it or we put it inside our map from our animation key path. So either return it directly, and if not, then we are going to create now our animation. So first of all, we are going to get out the different regions for our animation, and there is a nice function which is called find regions, which is part of a texture atlas. And because of the way we set up our file name, so with this _00, so with this indexing, with that specific naming convention, the find regions will find all of that together and simply return an array of these regions. So for example, for this attack animation, so if we pass in player attack, so find regions player/attack, then it will return those four regions here in order from 0 to 3, which makes it also easier to create now this animation. So that single line is doing that for us. Then the next thing that we can do, so if those regions are for whatever reason empty, then for example we passed in a wrong key or did not pack that yet into the texture atlas, so that for sure would be an error. So in that case we simply throw an error and mention here that there are no texture regions for, and then the animation key path. So what is this GDX error? That's just again a utility function, and what it does, it simply throws a GDX runtime exception which will shut down your game. So it's similar to the Kotlin error function, which I think throws a runtime exception if I remember correctly. So GDX error, which is part of LibKTX, will throw a GDX runtime exception. Okay, and if not, so if there are actually regions available, then we can create a new animation where we pass in how fast our animation should be played. So for example, 8 pictures per second. And what we then do for our regions that we have, which is, I think, array of atlas regions. Exactly. So those we need to map now to texture region drawables, which is very simple. So it's simply a texture region drawable, and we pass in the atlas region. And that's it. Be careful here. So I was a little bit confused now. So this map function here is actually an extension of KTX collections. So be sure to choose the correct one. There's it's a little bit difficult, let's say, because of the name clash with the Kotlin array and the GDX array. So that's why here you need to pick one. But that would be it. So we then have an animation. We play 8 frames per second. This is how I normally write it down. And the regions that we get out of the atlas will be simply mapped to a texture region drawable. And that is then stored in our animation cache. And yeah, if it's there, we simply return it, and if it's not there, then we will create it. So for that, let's also simply add some log messages that we know when this is happening. So let's create a log again for our animation system. And here in that specific case, let's debug that new animation is created for, and then our key path that we enter here. And also that one, we could give it a proper name. Let's call it default frame duration. And that is 8 pictures per second. Good, so with that, we have now our animation system in place. We have the animation component. We are setting already the drawable. Now in our game screen, what we can do here is now we add here an animation for our player and we play the idle animation. And for our slime, let's do the same. But here we want to play, for example, the run animation. We no longer need to set the texture region here in our image because this is now done with the animation system. So we can remove that part here. That is not necessary. The size is okay. Position is also okay. And yeah, let's see. Should work. Actually, it doesn't work, so let me let me show you that. So we can see that it's creating those animations, but it's not playing anything. And why is that? It's fairly simple. We are currently always going into that mode because we are never clearing the animation then in the end. So what we want to do when we set a specific key, so for example, we set the player idle animation, then we go in here. But what we want to do here then is that the next animation goes now back to no animation because we have updated it correctly. And then it goes up here and now it will increase the state time. And now it should play the animation. Which it does. So now you see for the slime, I think we set the run animation. So this is this hopping. And for the player, we have this idle animation that he just stands around and does nothing. Good. And yeah, that's it. We could actually add now some debug stuff that we change through the different player animations. But that comes then anyway in a later part when we then support movement and so on. For now, let's simply assume that our animation system is perfectly running, and we have optimized it also quite nicely because of the animation caching, which if you have a bigger game and maybe at some point you want to clear that cache to get that out of the memory and then fill it in with new animations, but for our game that is not needed. So since we do not have a lot of those things, we can simply keep it forever and just cache it for the entire time. And with that, that's it for this part. So in the next part, we are now going to introduce a support for the tiled map because, of course, it's fun and nice to create entities like that and programmatically set their size and their position and so on. But that is a little bit tedious then over time. So we want to have more visual stuff going on there. So that's why we are going to introduce support for tiled map, and then we can place the entities like the slime or the player in our map directly. And also we get some background and foreground scenery so that we don't live in this darkness that our entities are currently living in. And since it annoys me now a lot, let me also switch this atlas key here from an animation type. Let's also introduce a new enum class at least in the tutorial, to be a little bit better here than the code base on GitHub. Let's call it an animation model. and there we have a player, we have the slime, we will also have the chest later on, and there very similar, we have an atlas key, which is a string again, and it's the lowercase. We could use, of course, uppercase, then we just need to name our files differently. But yeah, let's roll with that for the time being. And instead of an atlas key, this is now, let's call it model. So that's a model, and that's of type animation model. And there, let's also have a default value, undefined. Which also means here we need to pass in not an atlas key, we want to pass in a model. And then it's from the model the atlas key. So that's now good enough. Let's check quickly our system here. Nothing needs to be changed. And now in our game screen, we simply can pass in here an animation model. Let's make it here the player, and below we use the slime. That should now work the same way, but now we have more meaningful enumerations for that and don't need to type that string all the time. Perfect. Okay, that's it. Thanks for watching and see you then in the next part. Bye bye.